So here we have the absolute value of 2 times c minus 5, and it is less than negative 3. So just a refresher on what absolute value is. So if we have the absolute value of x is less than 2, that would mean the distance away from 0 is less than 2. So we have our negative 2 here, our positive 2. We're saying if it's less than 2, that means that it is in between negative 2 and 2. It's just the distance away from 0, and those are open circles. Okay, if we actually had a situation where we had the absolute value is greater than 2 away from 0, then we would have a situation where we have a union. So the previous one was an intersection. This is a union where they're going opposite directions, because we're saying the distance away from 0 is greater than 2. So it's not at 2, but it's going to be further away from 2. So back to our original problem. So we see that this should be an intersection because we know that it will be less than negative 3. The distance away from, in this case, not 0, but 2c minus 5, will be less than negative 3. So let's rewrite this. So here we have the absolute value is less than negative 3. Now the key here is that you know the distance away from 0 or any number cannot be negative. So we already know that this is actually not possible. So we would put no solution. However, I wanted to show this example for 2 reasons. That should be solution there. I want to see what would happen if I did happen to have a positive 3 here instead of a negative 3. So if we had a problem like this where we had the absolute value of 2c minus 5 is less than, let's now go with positive 3, let's solve for that. So we have an intersection like we mentioned before. So I've written out our 2 cases. So we split this into 2. I always like to copy whatever originally was there into the first case. And then the second case, you flip the inequality and you make this a negative. So first, when you're on the second one, you flip and then make this a negative. So now we're in a situation where we have 2 different cases. So we're going to solve these, and I'm going to pause it and kind of jump ahead here. So if you look at this, you can pause it and look how we've solved it. We've done each step at a time, and we have shown both cases. So the first case and the second case, we flip the inequality and change the sign. So now I want to graph this. So I have c is less than 4, and I also am saying c is greater than 1. So can it be less than 4 and greater than 1? Yes, that is true, and that is an intersection. So if we were to graph this, it would look like this. Remember, this is open circle because you have the less than sign, not less than or equal to. So it's open circle, and it's between 1 and 4. Now, some people might solve it like I am about to in the following slide. It's the exact same problem, but instead of splitting it up between case 1 and case 2, we're going to do something a little different. So because it's less than, we can already identify that the distance is going to be an intersection, like we previously mentioned in the problems where we had less than. So now that we have that, I want to show how you can write this as an intersection. We would still write 2c minus 5 is less than 3. But now we're going to show the other end of the inequality. So we're going to also put our negative 3 down there. So we kind of show it all as one long inequality. And then we solve. So the key thing with here when you're doing this, when you add 5, we have to add 5 in all 3 spots. So we're adding 5 everywhere. Negative 3 plus 5 is 2. So we have 2c, and that's less than 8. And then finally we're going to divide by 2. And you'll see we get the same answer. It's just a little bit different format. Okay, so now we can see it's an intersection very clearly. 1 is less than c, which is less than 4. We're going to graph it the exact same way. We're going to go from 1 to 4, still open circle, and it's going to be in between. All right, great. Hopefully this is a good review for you for absolute value inequalities, and we will continue this study and have a great evening.